Hi, Dr. Pat here. We're looking at matrix multiplication. So in previous videos, we looked at how we can add and subtract matrices, and we also multiplied a matrix by a single number. In this video, we're going to start looking at how do we multiply two matrices together. But before I get to there, just want to do this example. Hopefully, it will make a foundation for us and make the process for how we multiply matrices maybe a little bit more understandable. Okay, so what we're looking at here are my sales for my Pie Boy Coffee locations, my little shacks. And I've got three locations, Edmonds, Lidwin, and Everett. And we're just looking at the sales for my lattes, mochas, and Americanos. And so we've got our quantities for each of our locations and drink. Then I'm also now giving you the price of each of those drinks. And so my question is, for each location, for Edmonds, Linwood, and Everett, can you tell me what the total revenue is for each of those locations? So go ahead, take a moment, and just kind of do that calculation by hand or with your calculator and see what you get. Well, hopefully you got these as your answers. And hopefully what you did was you took the 249, the price of the lattes, you multiplied that by 45. You took this 299, multiplied that by 234, and then 199 times that 13, you multiplied those numbers and then you added them together and you got your total sales. And then we kind of repeat the process, match up the price with the number of lattes, match up the price of mochas with the number of mochas, match the price of the Americanos with the price quantity of Americanos, and you multiply those, you add them together, and you got 523.39. And you just repeated the same process for the Everett location, matching the prices of each of the drinks with the quantities of each of the drinks, multiplied, and then add them together. Basically, what you have done is just calculated matrix multiplication. So let's kind of look at this in terms of matrices. So what I've done is I just kind of taken away, scratched out, just stripped off the whole chart kind of idea and made two matrices here. We've got our price matrix and then we've got our quantity matrix. This first matrix, you may recall, is a 1 by 3. It's a one row, three column matrix. And then this quantity matrix is a 3 by 3. It has three rows and three columns. And so that's what we're looking at there. So we got a 1 by 3 times a 3 by 3. Now, what did we just do in the charts? We took that 249, the price of the lattes, and multiplied it to the quantity of lattes. We took the 299, which was mochas, times the number of mochas, and the 149 for the Americanos times the number of Americanos. So what we're doing is we're kind of taking this row here and we're twisting it on itself to match up with these three numbers. Okay, so we're going to take that row and match that first column. And then that gave us the total sales for the Edmonds location. Then if we wanted the Linwood location, we would still take the 249, the 299, the 149, but then we would match it up with the three numbers there. Remember, we're taking each of these numbers and we're pairing them up with another number that's in the appropriate spot. And then we did it for the third column. Take this row of numbers, kind of tilt it on this edge, go 249 matched with the 65, the 299 matched with the 32, and the 149 matched with the 47. That's what we did if we did this by hand straight from the charts. So matrix multiplication does exactly the same thing. We take the row of the first matrix, kind of tilt it on its side to match up, to pair up with the numbers in the columns. Okay, and so this is only going to work if these dimensions here, the insides, work. Because I have to have three numbers in this row in order to match up with the three numbers in this column. See that 1 by 3 over here? That's telling me there are three numbers in each of these rows here. And then this first three here tells me there are three rows in each of these columns. So I've got to make sure that those two numbers match in order for me to pair up my numbers appropriately. So that is one of the requirements for matrix multiplication. When you put the dimensions of each of the matrix, put them side by side, those insides have to match. Okay, so when we do this process, we get exactly the same numbers. So I take the row of numbers here, pair them up with the column numbers, we get the 83108. And then we do it for the second column there. Take that row of numbers, match them up, pair them up with the numbers in that second column, multiply, add them up, and you get the second number here. And then once again, you multiply, pair up the numbers, multiply, and you get this third number here. Now, one other thing I want to bring your attention to the dimensions of the two matrix. We start with a 1 by 3, multiply it to a 3 by 3, and notice what we end up as our result. We create a new matrix, and it's the numbers on the outside. So when we kind of like line up our dimensions here, the numbers on the outside, that's the dimension of the matrix that we create when we multiply. So the inside numbers have to match, and we create a new matrix, and it will be the dimensions of the outside ones. Okay, so just kind of recapping the steps for multiplying matrices. Okay, we got to pair up the rows of the first matrix, and we're going to pair them up with the numbers of the second matrix, or the columns of the second matrix. So we're doing row column, that RC cola thing all over again. That's why you saw it on the previous screens. So pair up the rows of the first matrix with the columns of the second matrix. You multiply those pairs of numbers, and then you add the results. Kind of like that movie Hitch. It's all about matchmaking. It's all about pairing things up. And so that's what we're looking at. We're pairing up the rows of one thing with the columns of the other things. Just kind of like that Mars-Venus thing all over again. Rows, columns. So that's the math version of that comment of men are from Mars and women are from Venus. Men are from rows, women are from columns. It's a bad joke. I admit it. Let's move on. Okay, how about this? How about if we take this way I'm doing my pricing. So I redid my chart, and I did my prices this way. So I'm really playing with a 3-row, 1-column matrix, and I want to see, can I match it up with this? And of course, you're going to be telling me, dude, you can't take this price matrix here and multiply it to this quantity matrix. Why not? Because these inside numbers don't match. It's not going to work. So you've already stopped and said, well, dude, won't work there. But how about this? How about if we go the other way? How about if we take quantity times price? Because, you learned a long time ago that 2 times 3 is the same thing as 3 times 2. You both get 6 in those cases. But what we're going to look at here is matrices doesn't always work that way. So it's going to be really kind of cool. Later on, we'll show some prime examples. But now, how about if we do that? How about if we take the quantity matrix and we multiply it to the price matrix? Now, mathematically speaking, we're allowed to do that because the 3's match, and we would end up, mathematically speaking, a 3 by 1. But you're noticing I'm now saying mathematically speaking because sometimes the application and the mathematics don't match up perfectly, and here's an example of that. So here's the key why you got to have an understanding of matrices when you're in business and those kind of things, is because, yeah, sure, the technology will crunch it out, but you've got to set it up for the technology. And here's why. If we take this matrix, the quantity, and we multiply it to the price, remember, matrix multiplication says I take the row here of this matrix, multiply it to the column of this matrix. So look what's happening. I'm taking the 45 lattes from Edmunds, matching it up with the 249, which is the price of lattes, which is good. But then I'm taking the 128 lattes from Linwood, and I'm matching it up to the price of the 299, which is mochas. But wait a minute. That's a 128 to times out 299. Those are two different things. One's lattes, the other thing's mochas. And then when we finish up this row, the 65, which is 65 for lattes instead of Everett, from Everett, we're going to match up that number to the 199 because that's what we do. If we did this reversed way, switching the charts around, we would take the rows of this one times the column here, pair up the numbers, and now we've got pairings that make no sense whatsoever because I'm taking the quantity of lattes, multiplying it by the price of mochas, quantities of lattes from Everett, matching it with the price of Americanos. So if we reverse the order and we do quantity times the price, that's not going to work for us. And so what we've got a problem here is matrices. Switching the order of them, 3 times 2, 2 times 3 works great for numbers, but it doesn't work for matrices. So when you're switching the order, things don't work out. You've got to do a little bit more. Hey, I hope this made sense just to kind of get starting things. Just remember, row times columns. That's what we're doing. And pairing things up. One big matchmaking game. Hey, talk to you later. Hope this helped. Bye-bye.